So today, we'll be talking about large language models, in particular in manufacturing, but also very specifically on the shop floor, so where operators are working. And there should have been a Microsoft logo next to the Carlsberg logo that I represent, but we didn't find an official logo for the dark background. But please keep in mind, I'll also tell you about the project we are running together with the Microsoft on AI in manufacturing. So I'll introduce company and myself. I'll explain you the data environment. The initial analysis we did with Microsoft, and then how we are building on that, like what data we can use with AI, with large language models, what interface we could build, and how it can turn in the future. First of all, about Carlsberg. This is one of the companies when the company name is the name of one of the key brands, and that can create a bit of a confusion. In fact, we are much more than just Carlsberg beer. There are more than 140 brands, and there is a famous French brewery, Kronenbourg. Someone from the team organizing the event, we just talked that in Germany it is a Holstein beer. There are many more national, regional brands, and we own some craft breweries. They kind of operate independently from all the corporate system and standards. Their own creative way of working. You can go to the website and try our products. They're amazing. And we are more than just a beer. We are one of the biggest bottlers of PepsiCo in Europe. We are as well partners with Coke in some countries. We produce water, energy drinks, high quality craft lemonades, and many more. About me, I'm a production guy. I was always working in production, head of department, plant director, Russia, 2 African countries, 6 years in Africa, and almost 3 years now in Switzerland, where we have Carlsberg Supply head office, and currently I'm responsible for maintenance and asset care in Western Europe. The reason why I'm here is I'm actively involved in digital transformation. And it's a nice term, but for me it is about tools which are practical and which people use and like, and that generate value for the company. Obviously, we are as well experimenting with AI, and my background is engineering and a business background. And in between 2 corporate jobs, I had some startup and board experience. Well, now let's go to the manufacturing shop floor. It's very easy. This is Kevin. Kevin has the machine, the modern machine, highly automated machine. He has packaging materials and energy for that machine, and his job is to produce the finished goods. Very simple. Well, maybe not so simple. The managers would probably ask Kevin for something more. They would ask him about efficiency. Production lines in the industry overall, I'm not talking particularly about Carlsberg, in the industry, production lines can lose up to 40% of their operational time. What does it mean? It means if the line is designed to produce 10,000 bottles per hour, you are not getting it as an output for multiple reasons. You have planned events, which are non-negotiable, as cleaning, as hygiene, important for quality. But you also have the unplanned events, such as breakdowns, when one of the machine components gets broken, or operational stops when something is jammed, some kind of malfunction where nothing is broken, but still you need to intervene and fix it. And those inefficiencies together with the scale of the production side may potentially double and triple the production cost. So they can make the company uncompetitive. And there are plenty of examples of the bankruptcy because of the supply chain and manufacturing inefficiencies. What companies do to be efficient, there are various continuous improvement initiatives. I will talk about it at the next slide. So there are continuous improvement or total productive management experts, and they, with a team, they try to analyze the problem and they try to bring improvements. But the problem is, it is often very reactive, because obviously these experts are studying these problems after they occur. And another problem is that Kevin, and people like Kevin, the operators, it's sometimes, or quite often, very challenging to involve in this process. Because they're working shifts, they're producing. I mean, to involve them, we need to take them out of the shifts and create a space and create a time and so on. And besides, it's a teamwork, so there could be that he and his colleagues are in another shift, and it's quite difficult to connect. Those of you who were who worked in production and experience for sure know that, but for others, I need to mention, because that's connected with the data. Companies run programs that can be named as operational excellence, total productive management, lean manufacturing. Some companies have their own names, or they don't even brand it. Yeah, they run these improvements themselves. Some companies hire external consultants to build this system, to build this expertise. It all mostly started in the post-World War II era in Japan, the country which had very few resources and had to compete through efficiency. And mostly it is about various problem-solving tools, root cause analysis. It is about process standardization and documentation, and also about training and people development. Smart companies invest a lot in people. Good processes visualization. 5S is the methodology to make the workplace efficient, and other improvement initiatives. All of that, or the purpose of all of these tools, is to systematically reduce or ideally eliminate all the inefficiencies and losses. And this could be production equipment inefficiencies that I talked about, labor losses, energy and water losses, material losses, quality defects and rework. Obviously, if you produce non-compliant goods, you will never release them. Quality first, you will scrap it, and it is a loss to the company. And labor loss is very interesting. If you have a situation that two colleagues and two departments are doing the same report, or nearly the same, double reporting, it can be considered a labor loss. Or if the line is not reaching its efficiency, you kind of pay more per unit produced, yeah, because you take more time than you could. Now, if you look at all of that, all I've mentioned on this slide, to run that efficiently, we need data. It's all about data. Actually, all those methodologies start with analysis as the first part. And what Kevin has as the data. Quite a lot. I on purpose made this slide a bit chaotic, because it's all a bit chaotic. Yeah? The process is very dynamic, and quite a lot of data around. There are upstreams and downstream technological processes involving logistics. There's, material quality. There could be slight fluctuations, which, in combination with, with machine settings, may not work and can create stops. There could be some activities done in the other shifts, which Kevin is not aware of. There could be his own way of, operating machine, or there could be a useful data in the machine manufacturer instructions. All of that, in theory, can help him. And we know that from actually our problem solving that quite some problems are complex. It's not just one thing. It's all connected. And here I want to talk particularly about machine internal data. This machine, which you can see on the left side of the slide, produces 2,000 cans per hour, per minute, and 120,000 cans per hour. It can look quite simplistic. Well, it is huge. It takes space. And it looks simplistic due to hygienic design, because on the outside there are not many things. But believe me, it is a very, very complex machine. And this is just an example of one machine. And every modern machine is highly automated. So there are plenty of sensors. There are plenty of inputs from HMI. There is a program algorithm, and all that goes through PLCs. We can for sure say that an average automated machine has between hundreds to thousands of data points. Just one machine. And we may have 10 to 15 machines per line. We can have 10 lines. We can have a brewing department with its own sophisticated technological process. So you can multiply. We are talking about huge, huge amount of data. You probably have seen a lot of icebergs in your life. Usually we use it to show that part is hidden or not visible. And today we are looking from the shop floor perspective, from Kevin perspective, and quite some data is not actually visible or cannot be utilized by Kevin and his colleagues. What they mostly use is production output, some high-level operational data, quality things, some control screens, as we call them, HMI. There are many other things which are actually not visible. Some of them are not accessible, and quite some data that you need to have a capacity and knowledge to be able to interpret and use it. So you may need to have several engineering degrees to be able to process this data, connect it together, if you're supposed to work with that alone. And when we try to estimate what data we have, we realized that even the task to just label or make a complete list of the data points would be very, very costly. Just machines alone, we discussed, this is, I don't know, 50, 100,000 data points per brewery. But, well, you know where I'm going to. Obviously, it's about AI. What if we give Kevin a little help, and we call it augmented intelligence? What if we give him something to cope with this very quick technological process, 120,000 cans per hour, and with all this data that potentially can help him? That could change the game. Now, for the moment, I would like us to abstract from all this overwhelming data. I have taken this picture at the western coast of Sweden. There is a charming, beautiful town called Falkenberg. Is there anyone from Sweden in the room, by chance, if you could raise hands? Yeah, there are. A beautiful country. But the fact that we have it in the presentation is not due to this reason. Last year, Microsoft approached us and proposed to do a pilot to see how can we utilize artificial intelligence in production. And of course, we started to think, where can we do it? And Sweden is not just a beautiful country. It's known to be one of the top in terms of innovations. So it's quite innovative, and we noticed in our own brewery that we have there that the team is open-minded. So we decided to run a pilot project together with Microsoft. Now, I think it's more than 30 people from both sides are involved, from the brewery side and from Microsoft. And at this point, I have to tell you that Kevin I was referring to is actually real. Kevin is one of the operators of the Falkenberg brewery. And when we started the project, we realized we have some enthusiasts, including him, who already experimented with AI in production. ChatGPT and other things. And as you can imagine, you're very limited because you always need to feed in the data, and it's not always convenient. Nevertheless, he had some brilliant ideas. Now he is part of the project. The power of data. When we started with Microsoft, we gave them some data. And without seeing the line, without knowing the process, they started just to look at it and try to see to draw some conclusions from that. And there are things we never looked at and never thought of. So just from the data, without knowing the process, they could find out that some shift handovers are causing more stops than the others in a particular moment of the day. They could see some patterns in the changeovers when we change from one product format to another product format that we could not pick. And interestingly enough, maintenance. We do maintenance, and we, of course, expect a better outcome, a better performance after that. But we could see that sometimes, after maintenance, the performance drops. And more, the very short stops are commented by the operators in the so-called MES system. And as you can imagine, everyone has his own language and way to name and to describe it. And they were able to cluster it and to provide a very insightful analysis. So we could pick some quite significant problems that we weren't aware of because they were commented differently and they were not clustered properly. Building on that, obviously, collecting data or using the data for AI and building this collection, everything is time-consuming and has a cost. So we started to think what data we can include in the project to solve particular problems. And this is about these comments clustering. This is about changeovers and production orders. This is about maintenance data. And another purpose. And we established 3 directions and 3 horizons of this program. The directions are coaching, collaboration, and consistency. Coaching is where we can educate our people. Collaboration is about better communication between our teams with the support of AI. And consistency is still about making processes more standard and more repetitive. And currently, we're in between Horizon 1 and Horizon 2. which is making all these data from different sources accessible and visible, and involving large language models starting processing and use that. And the future is prediction and prevention, which I will talk about in a few minutes. We identified 5 strategic areas for the user interface and the app. I will show you mock-ups in a minute, but it's about production performance, downtime, assistant, changeover, shift handover, and some advanced analytics. Well, all the data you see is not an actual production data. It's just a mock-up of the interface. And in that production dashboard, quite some things, they do not even require artificial intelligence, but some do. It's just one of the screens or dashboards of the app we are developing. And that example where large language models play a key role is about troubleshooting, is about problem solving. So just like you're using Copilot or ChatGPT, you can get actual insights about your process, about your machine. But all of that are data visibility and the stage of augmented intelligence. What about prediction? Actually, nothing new. This is an IoT Congress, and of course, I should mention some IoT stuff. These are IoT sensors, condition-based maintenance sensors. In this particular example, vibration sensors, and they can pick some enormous vibration in a certain pump or motor or bearing, and that give you an indication. Please replace and repair it before everything breaks, and that will cost you much more. And here there's nothing about AI. It's quite old technology, and it's based on algorithms. We as well experimented with the robots from Boston Dynamics and their competitor Anybotics, Swiss company. And the task of this robot is to walk through the plant and check a certain inspection points. Visually, thermal sensor, vibration, and so on. It's very nice. It's exciting for employees to see that. Whether it's valuable compared to its cost, we are not yet sure. Also, no artificial intelligence currently, but Boston Dynamics have plans for that. But there are plenty of disadvantages. You can't place the sensors deeply inside the machine mechanics. And the robot will do a walk once a day. So you may miss this critical moment when you have to stop and intervene. Still, that we will use these sensors in certain places, and we potentially will use robots. These are all extra assets, extra cost, extra maintenance, replace the battery if you need a higher frequency of data supply from the sensor. That will drain the battery faster, so on and so forth. What about the data which is already available? Please be careful with the title of this slide. It's not casual AI, it's causal AI, from the word cause. The cutting edge, of the industry is the industry where they save lives, and I think it's very inspiring when you read things like it can predict a certain disease up to 6 years in advance before it appears, using computer tomography, which was invented in the 1960s. So we have all data that was available before, but machine learning, AI, and large language models can see those correlations and those causations that we didn't pick. Yeah, computer tomography is very old. So what if we use the same logic for the manufacturing shop floor? As we said, we have plenty of data, and instead of building extra sensors and adding extra assets, maybe we could start using more of the data we have. Here we need to deep dive into details. That's one of the last slides, and I would like to ask for some attention. This is a bit of a classical process of problem solving on a production line. You have obviously an unplanned stoppage, which could be a breakdown or, as we said, operational stop. Then you need to fix it and make it run as quick as possible. And here we differentiate fixing and having a final reliable solution. So here and now, just make it run. Then, of course, you report this event in a different system. And then already afterwards, you're making a deep analysis that can be called root cause analysis, breakdown analysis. There are different names for that. But they're aimed to understand what is the real underlying cause of all these problems and to implement preventive solutions so that this type of problem does not happen again. If it does not happen again, by solving more and more problems in a reliable way, you're building up the efficiency and you're increasing that. As you can imagine, this analysis and troubleshooting sometimes takes hours and days because you need a lot of data from different sources. It takes time to extract some data. It takes time to get the data from supplier, from your old technical library, which some still have hard copies. A few weeks ago, I was participating in a root cause analysis of a big event, and it took 3 days to draw a preliminary report with high-level hypothesis. 3 days. It's not even completed. 3 full days. Yeah, we all lose a lot of time. And please remember our iceberg, the data we are not using, and that Kevin, with augmented intelligence, could potentially get more from that. And here again, I'm talking particularly about Kevin, not someone else, because he's at the line. He has the chance to respond quicker. He has the chance to fix it quicker. It's not some expert, some engineer. He is out of the line. He will come likely next day, or he will come with a delay. Kevin is the one who can fix it, who can respond instantly. That is the old process. And what if we involve and include large language models? First of all these machine data that we have thousands of and other operational data, we can feed it in, as well as the data from reporting about the stops, but also the data of previous root cause analysis, so that large language model gets trained on the particular problem solving that we have. And it's very interesting that we have many plants around the world, and it could be that one problem was already solved in China, and the same problem appears in UK. And currently, it is very difficult to connect it because it's a different language, different name, and so on and so forth. So we are inventing the bicycles all the time, likely. So if we give it all to the AI, that can transform significantly our classic ways of working. First of all, like these sensors, but without having IoT sensors, that can give us predictive alerts that it's time to make maintenance in a certain part of the machine. But it can also give us an urgent alert that something is about to break. Stop it, or that will cost you more. Then the moment of troubleshooting sometimes it can take hours and you just don't know what is going on. Kevin doesn't know what is going on, and his colleagues. And we think LLM can accelerate it significantly. So the troubleshooting, where to look, what to check, and so on, what to adjust, can be very insightful and can help solve it faster. And as well, support in the process of root cause analysis. Once you have a problem, it's not even easy to start, proposing the hypothesis, which is one, which is the second, and so on. And based on the history on that can give us a lot. Just to summarize, so as we said, currently in the industry, most of the shop floor low-level data is not utilized simply because we do not have the capacity. It's too many data. We are too few to utilize it using our own brains. But this data is a treasure if we use it for troubleshooting, for root cause analysis. It will be a completely different speed and quality of the problem solving. We think that in the future, the augmented intelligence can transform the working environment significantly. The working place can be much more fun. It can be much more interesting and enjoyable for Kevin, and at the same time driving higher efficiency for the company and higher value. And with that, I wanted to underline that doing all that, we have zero intention to replace Kevin. Our intention is actually to retain Kevin and his colleagues. With that, that's all I wanted to say, and we have some time for questions and answers if you have those. Yeah, we have one here. Do we need the microphones for that? Yep, there's one question here.
Thank you so much for your presentations. Really exciting. I have just one question about the three graphs or orbit you talked about.
Three horizons.
Three horizons, yeah.
Yep, going there.
And yeah, so the question is, the first one is fairly standard. I couldn't understand the second part and the third part.
I would say the first one may look like a standard one, but we still think we have very few examples where we gather all the data from the different sources. The machine manufacturers, they are not so much interested to make this data, for example, accessible, and because they have a certain revenue streams related to the services and so on. And when we come to ERP systems, in theory, you own the data, but when you want to export it, it's not always easy. So even the first stage, it may look basic, but it's very hard to do because some data is hardly accessible, and we even have to negotiate with our suppliers to get it. This simple thing, the more you put in, the more quality data you put in the LLM, the better answers, the better analysis you get, more precision and so on. So the second is, in theory, is the same thing like ChatGPT, or let's say advanced model like O3, or maybe slightly better, which is able to reason. But it builds on this first level where need to feed in sufficient amount of data so that it starts giving us reasonable and valuable inputs. So again, pretty basic. In theory, it is all available. To do it practically, not that easy, if that answers your question.
So the second line itself, the data you are training is basically taking data from your production and simulating it?
Yeah, there is a mix of, let's say, general data from from the external environment. And we are discussing, what proportion should we have of external data and internal data. So it's a mix, but the priority is internal data, and we need to train the model very well on the internal data, because that's relevant for our machines. Otherwise, you will get a very generic answers like, push this button, the button that you don't even have on your machine.
The last question I have is on the sensor data on the left-hand side, right? The sensor data, are you getting sensor data or are you getting something else?
Sorry, I don't hear you well. And where was the microphone? And maybe others need to hear you as well.
The first one, the red side, you are collecting, I remember the slides, you are collecting data from various sensors, all thousands of data points, right?
Are you talking about this one? Or
No, that's same graph.
The same, this
That's
one?
right, yeah.
Yep.
So you're collecting data from all the sensor, all the data points, right? And are you getting just raw data or getting the metadata along with it? And you want to contextualize with your reports, like how you did this Copilot phase 1?
Well, here we are, entering the stage that even to agree to present the mock-ups I had to discuss that and agree that with Microsoft, because we have mutual NDAs. So I think we are entering the field I cannot disclose, unfortunately. Yes, please.
Actually, the question was, is there any platform Microsoft come with you for collecting the data? Because normally, in a shop floor, you have MES data, you have data coming from HMI, SCADA, lots of data are there. So is there any data warehouse platform you had implemented and collected the data initially, or how the process is? Because it is a scattered process. There is no standard way of data collection in a huge environment.
Yeah. Here, I have to be careful with my answer, because I'm not a data expert. But what I know is Microsoft, of course, helped us a lot. And there is a cloud, I don't know the proper name of that solution, where this data is collected from different sources. So the brewery team is finding the ways, how to extract it from the different sources. And then there is a Microsoft solution, which is a kind of accumulation of all of that.
Okay, this engagement is with Microsoft did this engagement. Microsoft did this one for the data collection, or it has been done from your side?
It's done together, and again, it's quite technical, and I may not know who exactly does what part, but it's a joint effort, and Microsoft is heavily involved.
Thank you.
Thank you. Are there any other questions? We still have time for one, I would say.
Thank you for your nice presentation. I have a question. I know you only started last year, but do you already have some results that show you that you're on the right direction, or?
Proof of concept.
Exactly.
Actually, now, it's this particular week, I've seen a lot of messages in our chat, which is a chat between a Swedish team and Microsoft. And we are testing it. So we have various dashboards and various tools, much more than actually I could show you for the reasons you can understand. And it is very, very promising. So Kevin himself is happy. It seems to be working. Of course, we need more time to confirm that, yeah. But seems to be promising so far. Any other questions? Yes, one more question. Can we give a microphone, because that could be interesting for everyone.
My question is related to the data collection. I know you said that you're not expert on the data collection side, but still I will ask the question. Maybe you can answer it. You said the data which is collected from the shop floor, right, which is you have thousands of data points, right? So this is all raw data. This is not the filtered data. This is a raw data. And some of the data is like junk, for example. It's not of any use. So where is the filtering done? Is it done on the Microsoft platform, or is it basically the data is filtered at the brewery and then basically it was sent to the Microsoft platform? So how was it done? What was basically used to filter the data, or you can say a sensible data for the analysis?
It's a very good question. And that example of machine data we discussed, let me get to that slide. Yeah. We are talking about data labeling. Yeah? Quite some data is unlabeled. So you can have a certain variable, it changes. You can guess it looks like the range of the pressure, it behaves like the pressure, but it is unlabeled. And obviously, Microsoft cannot do that. What we do with the local team is we try to feed in the data which is mostly labeled and structured. And if there is something critical we think will help and will be needed, then we label it if it's not too resource demanding. Otherwise, there's always a solution to reach out to the manufacturer of the equipment or to the provider of the service or data and get it.
About thousands of data points, right? Thousands and thousands of data points. You talked about 15, lines. So filtering the data point by point is going to be a, very difficult task. So was there any, tool actually used for the data cleansing? Because I know filtering the data point by point is not something basically, you will be doing. So you might be using some kind of a solution or, a tool to cleanse the data based on some parameters. So.
Well, actually, we are using data cleansing tools not in this project, but in other projects, which is not the scope of the presentation. In that particular project, we didn't yet use something like that because we still have significant amounts of labeled data. So it's not, making this 95% invisible iceberg in one shot. It's starting using 10, 50, 20%, which is already visible and labeled and well structured. So not yet, but it is likely to come in the future. Okay, probably one last, because otherwise we are running out of time.
Thank you. Great presentation.
Thank you.
You mentioned on one of your slides that the continuous improvement team would typically jump after the problem has occurred using lagging rather than leading indicators. So what's your vision now, knowing what you know, to integrate, going beyond Kevin?
Mm-hmm.
How do you see all this platform and continuous source of new data, recommendations, call to actions to help with continuous improvement? Because ultimately, I think these guys have to be integrated into the process. Is there any idea how you're going to use this for your continuous improvement activities and processes?
I'll try. It's a fantastic question, and probably I would need more time to respond to that. I'll try to answer very short. Look, we had two key players in the classical setup. That was Kevin, the shop floor, and there was these, let's call them experts. Now we have the third player, which is AI, in a sense of support to Kevin and others. And obviously, AI, or this tool, will take part of this job, part of these activities, thinking and problem solving from both sides. We think Kevin and the shop floor will be able to do it more, quicker, faster, and higher quality. probably these methodologies of continuous improvement, of total productive management, they will also transform because we will have much more opportunities from problem solving. So I would expect that these methodologies and practices would be developing, and how, it's too difficult to predict. With that, we are over time. Thanks a lot. Thanks for your attention and questions.